Hello, Professor. Hope you are doing great today. I'm Sharon Mathapati and I'm here with Lahiri Mahasaya, my teammate, to explain our project, demonstrate our project regarding the enhancing security and logging in apartment complexes. We have developed a advanced database system regarding this thing, and I would like to discuss more regarding this project in the upcoming slides. Yeah, coming to the problem statements. Coming to the problem statements, we have various problems regarding this apartment security systems. Like we don't have the sufficient security systems in place to guard this apartment security. We don't have sufficient logs, kind of thing, which helps in improving the security of the thing. That is the major privacy concern. I mean, major thing for the security. And after that, we have this delayed incident identification. Say there is a robbery occurred in an apartment. There is a delay between the identification of this robbery because you don't have comprehensive logs for that to identify that immediately. Uh, After that, we have this privacy apprehension for the residents. Say, if you are a resident in such apartments, you don't have the confidence to live in those apartments because it doesn't have this proper security systems in place. So that would demoralize this residents in place due to the privacy concerns and also ineffective post-incident investigations. Like there is a robbery happened and you don't have this comprehensive logs to find what has happened. So the post investigation would be definitely ineffective as you don't have the sufficient evidence for that. And also there is a high demand for this integration of this logging systems with the database, so that when you integrate this database, this logging to the database thing, you can store the whole logs of this logging in the database and you can retrieve whenever you want. They are right at place so that whenever incident you can jump to those logs and get those logs directly. Moving on to the next slide. uh, Here we have the various, I mean, the solution which we have proposed for this kind of security system. To improve the security system, we have a proposed solution in place, like comprehensive logging with the database integration. We are trying to design a database which incorporates all the logs regarding the entries, exits, and also regarding the face recognition technology. We have a face recognition technology in place so that you can directly have the face recognition technology to match with the resident, so that if that gives you an idea if that's a resident or not. And also this real-time incident response to database. You have this real-time logs as soon as the person enters, or let's say the resident enters into the apartment, you log that, so you have the real-time logs for that. And also when such security systems are in place, it gives high confidence for the residents in that apartments to stay in that, so they don't have any privacy concerns, or they will be, I mean, they are confident that we have such security systems in place so that they are not worried about the security. So next comes this post investigation with the database record. Say something unusual has happened in those apartments, like be it a theft or something. You have this logs directly. There would be no delay with the between this investigation kind of thing after the incident has happened. So yeah, the final thing is that we are integrating this whole set of logs to database systems. As I previously discussed, we will be entering all the log data into the database system so that we can retrieve whenever we want. This is the proposed solution which we are having. Let's move on to the next slide. Yeah, here comes the ER diagram, which is nothing but the entity relationship diagram. Here are the various entities which we are having in our project. We have majorly four entities where access log, residents, and point ID. Point ID is nothing but beta 8. It is nothing but entry point or an exit point. It gives you more idea about if it's an entry or an exit. And apartments, the various apartments within the complex. This is a simple entity relationship diagram which we are having for this project. We will discuss more about these entities and the various attributes within these entities in the upcoming slides. Yeah, this is coming to the tables which we are having in this database system project, access log is one of the important table which we are having in this project, because this is the one which logs all the entries and exits, and which ties it to the residents and also the apartments in the apartment, I mean the complex. So I would like to explain each and every column within this table. Like access log ID is nothing but a unique identifier, be it a primary key. You need to have some kind of primary key to uniquely identify that record. And resident ID is nothing but a foreign key which ties to the resident table. So resident ID is like if there is a resident, you'll have a unique ID for them. So yeah, that's the resident ID here. And the timestamp. Timestamp is nothing but at what time they are entering and what time they are leaving. So that's the timestamp. And recognition confidence is something which relates to the face recognition technology. It gives you more idea on how close match it is having with the resident. Suppose you have an image stored in your system, and there is a there is an individual in front of the system, so it can match both of them. And what is the recognition confidence it gives out? And the status is nothing but this entry or exit, whether it is an exit or entry, it gives more details on that. And the apartment id is nothing but the unique id given to each apartment. And point id, as I previously discussed, it's an entry or an exit point, and it gives the name of the point. Move on to the next entities. Coming to the apartments table, apartments table is a simple table regarding the apartments, and it only comprises of three fields. They are apartment ID, it's a unique identifier; apartment name, it's a common name given to the apartment; and the apartment type. It's a kind of category which you associate with the apartments, like based on the luxury or the security features in it. You may categorize that as bronze, silver, something like that. So coming to the next entity, it's a point table. I mean point ID table. It gives you, as I told you, right? Point ID is nothing but a entry point or an exit point, like entry gate and exit gate. This is something like that. So it has two columns. They are pointed. It's a unique ID for that, and the point name, like front gate, back gate, something like that. Let's move on to the last and the final entity. That's the residence table. Residence table is the ones which uniquely identifies the individuals staying in the apartments. They are the residents, and the columns in the residence table are residence ID. It's a unique identifier for each resident. The first name for the resident, the last name for the resident, and the face image path. Face image path is something like we can't directly store the images of the individuals in the database, right? As it's a relational database, it's hard to store the images directly in the database. So we have a file path to the image which is already stored in the cloud. So the last one is the apartment ID, which is a foreign key for the apartment, which represents the apartment ID. So you can link both the residence table and apartments table together. These are the various entities which we have in our database project, and the next slides will be continued by my teammate Lahir. Thank you.
Hi, Professor. My name is Lahiri Mahashia Vesta. Prior, my teammate has explained you about the entity relationship diagram and as well as the tables which are present in our database project. So now I will be explaining about some of the queries which are important for our database management system, because using these queries we can fetch a lot of useful data which is required for showcasing the results as such as logs, entries, and exits. So let's dive into it. So here like we have the access log retrieval, where I am selecting access log ID, timestamp, status, recognition confidence from the access log table, and I am selecting first name, last name, and the face image path from the residence table. And from apartment table, I'm selecting the apartment name from which the residence belongs to, and the point name where the resident has entered, from which point he has entered specifically. So using this, we will be getting the details of every detail of who all has entered the apartments and what all, where he has entered and who is the resident and where or which apartment he belongs to. So let's dive into the real instance. So this is our project which we have created in MySQL. So if you see, MyDB is our the project name. So we have the tables, access log, apartments, point ID, and residence tables here. So if I go to the access law of retrieval table, so if I execute this, I will be getting all the details which have there in the database, like which person has entered at what time and whether he has entered, whether he has exited the status wise, and as well as from which point ID he is entered. So this is the first select query statement. And let's go to the second one. So the second query statement tells us about the apartment entry and exit count, by which we can know that like which apartment has a huge amount of traffic and which apartment has less number of entries and less number of exits. So for the comparative analysis between the apartments, so let's dive into the MySQL to run this query and let us know what is the how many entries have happened from one particular apartments. So if you see, like we have here one, two, three, four, five, six apartments. So in the six apartments, these are the number of entries, these are the number of exits which happen from each person. So these are the like by this we can know that like the block A, the apartment A has most number of people visiting when compared to the others based on the descending order which it has showcasing. So let's dive into the next query, like how it will be. So the next query tells us about the residence entry and exit count analysis. So by which we can know that who is the resident who is visiting, so like multiple times to another apartments, or else like which resident is going to which apartment in which time stamp. So here, like if you see, I am taking the existing counts as like from the residence ID, first name, last name, from the basis of whether he has entered or exited. From the residence table, I am joining the access law and as well as the resident ID. From the, like we are merging them and we are grouping them with the name of residence ID, first name and last name. So here I am selecting from this table. So we will be getting. Let's dive into this live example from MySQL and let us know like what is the residence entry and exit analysis. So if you see here, like John Doe is a person who has entered and exited multiple times, approximately 9 times he has entered, 8 times he has exited, and his resident ID. And these are the residents, and these are like all the resident IDs, and these are the residents who we have, and these are the entry and exit counts which they have done. So let's go into the next querying statement and let's see like the next querying statement will be actually timestamp basis. Like if you see like there might be some scenarios we wanted from this time period to this time period, how many people has entered into the apartment. So for that, if I run this query, we will exactly know how many people has entered in this particular timestamp of 23rd November 1st to 23rd November 30th midnight. So these many people have entered into those apartments, and this is the confidence with which they have recognized each time they have entered. So there might be multiple entries because based on the dates. So the John Doe has entered today, he might also enter and exited tomorrow as well. So that's why we will be having multiple rows as well for each person, and we'll be having separate confidence. Whenever he enters, it will be recognized and the confidence will be updated accordingly. Uh, so this is the total queries which we have executed, and let's go to the next steps of this project. So the next steps of the future development of this project will be optimizing the database performance through indexing and querying optimization. So and also implementing a strategies where we will be archiving or purging the data. So rather than archiving or purging, like we are thinking of like dumping whole data into the like cloud-based database systems such as Snowflake, by which we will be having backup of everything, so we won't be losing any data, and also utilize database monitoring tools in real time to get insights and as well as performance metrics. While we are using this cloud-based database systems, we will be also implementing the role-based access control, by which we can give access to only certain number of people, by which we can prevent the data leaks, and which will help us to keep the privacy, as we have lots of personal details in this, as we have residents names and as well as the residents images. So it is like it is our first priority to keep it private, to give privacy, to maintain the security of the data. So for that, we need to restrict the access to the less number of people, and also only give to the heads, security heads, or else the apartment heads. So these are the future development plans which we have for this project. So thank you, Professor, for giving your time, and hope you are having a good day.